Hello everyone, myself Dr. Sree Lakshmi, Assistant Professor in the Department of AIML at Institute of Aeronautical Engineering. In this session, I am going to discuss about method of false position, and it is also known as Regula Falsi Method. And this method is used to find out the roots for the given polynomial. This Regula Falsi position method is improvement over slow convergence of bisection method. In bisection method, more number of iterations required, but in Regula Falsi position, we will get the root value within minimum iterations. To find the root, input is the searching interval containing the root a, b. The initial guesses should be a, b. And then the tangent is joining a, f of a and b, f of b. The point where the tangent touches the x-axis is the point of interest. Now, to apply this algorithm, choose two initial points a and b such that the function at those points have opposite sign. And same as the bisection method, the initial values a and b need to be selected. And here is a condition that f of a into f of b should be less than 0. Step 2. Calculate the point C where the linear approximation intersects the x-axis using the formula. Here, the formula to find out the C is not same as bisection method. In bisection method, we used a plus b by 2, that is interval halving. But here, the C is a into f of b minus b into f of a by f of b minus f of a. This is the formula to find out the C value. You can consider as x0 and x1, and you can replace that with C replaced with x2, and here the function is x2 is equal to x0 f of x1 minus x1 into f of x0 divided by f of x1 minus f of x0. If you consider a, b values, then C is equal to a into f of b minus b into f of a by f of b minus f of a. If you take x0 and x1, then x2 terms, x1 terms and x0 terms will be applied. Now third step is determine f of c. Once you find out c value, now step 3 is determine f of c. Same as in bisection method. And here, if f of c into f of a is less than 0, then root lies between a and c. And set b is equal to c. If f of c into f of b is less than 0, then the root lies between b and c, and set a is equal to c. And even this is same as bisection method. Based on the f of c value, the a value and b value, that is the roots initial guesses will be changed. And step 4, repeat the step until f of c is less than a predefined tolerance level or the interval a, b is sufficiently small. So here is a graph for Regula Falsi position where a need to be calculated, b need to be calculated, and then we need to find out a point a into f of a and b into f of b, and then the root lies in this interval. So wherever it bisects, that is the point of interest. Now, what are the advantages of Regula Falsi method? This method is very easy because it is very basic in the structure. This backtracking method can guarantee the convergence if the function is continuous within the interval. Unlike the Newton-Raphson method, the Regula Falsi method does not require the computation of derivatives. And when we move on to the Newton-Raphson method, we will see how it works. Because derivatives in the sense, here if I consider f of x is equal to x cube minus 3x minus 5. This is my function. When we are applying Newton-Raphson method, I need f dash of x, which is 3x square minus 3. So when we are working with Newton-Raphson method, we need to find the derivative of the given function. This is an advantage of Regula Falsi method where we are not using that computational works. And what are the limitations for Regula Falsi method? Regula Falsi, compared to other methods like Newton-Raphson, it may be slow to converge. Though it is better when compared with bisection method, when compared with Newton-Raphson, it is slow. The speed of convergence depends heavily on the choice of initial interval. So the initial guesses, whichever considered, that should be approximate, and to increase the speed of convergence, we need to select the initial interval as good. The method can sometimes exhibit oscillatory behavior around the root. So repeatedly might be the iterations, when you are moving on to the iterations, without getting the similar value, we may continuously get different values. So leading to slow convergence. So more number of iterations will be increased. And here is an example where we will apply Regula Falsi position or Regula Falsi method. Find the root of the following polynomial function using bisection method: x cube minus 4x minus 9. So f of x is equal to x cube minus 4x minus 9. And we need to find out the first step. A is equal to, assume 0, then f of a is equal to minus 9. Next, other value. I will take b is equals to 1. So f of b is minus 12. Again, I will change this value. Just I am going to consider, instead of a, b values, just I will take x is equal to 2. So f of 2 is equal to minus 9. And x is equal to 3. F of 3 is equal to 6. So we got a negative value and a positive value. In previous case, when you consider 0 and 1, f of 0 is minus 9 negative, and f of 1 is also negative, f of 2 is negative, f of 3 is positive. We can choose the initial guesses as a is equal to 2 and b is equal to 3. We should not consider a is equal to 0 and b is equal to 3. These initial guesses will not give the root value immediately, because since the interval length is more number of iterations will be taken. Instead of that, we need to select a is equal to 2 and b is equal to 3. This is first step. And what is second step? Finding out the c value by using the formula a into f of b minus b into f of a by f of b minus f of a. So what is it? So a is how much? 2. F of b is how much? 6. Minus b is 3 and f of a is minus 9. Divided by 6 minus of minus 9. So this value is 2.600. I'm going to take up to 2 decimals or 3 decimals. So let us consider up to only 2 decimals. So C value is 2.60. Now, what is f of C value? What is f of C value? F of C is 2.60 whole cube minus 4 into 2.60 minus 9. So the value of this is minus 0.384. Since this f of C is negative value, we need to change f of a and then a value. A and then f of a value. Similarly, the iterations will be continued. So let us take a table here. Iterations. A value, B value, and f of A, f of B not required. If we want, we can consider also. f of a, f of b, c, and then f of c. So now for the first time, for the first iteration, a is equal to 2, b is equal to 3, f of a is minus 9, f of b is 6, and the c is 2.60. I'm taking only 2 decimals, and f of c is minus 0.384. And now, since it is negative value, we need to change a value 2.60 and b as it is. Now, f of a is how much? Minus 0.384. And f of b is same. Now, the c value is how much? So, we need to find out by using the formula. The formula is continuously this f of a, f of b and a, b values will change. Based on that, we need to find out the c value. For the second iteration, we got c is equal to 2.62. I'm going to consider only 2 decimals, up to 2 decimals. If we want, we can move on to 3 decimals, 4 decimals as per the question given. And now f of c is the function we know that x cube minus 4x minus 9. Substituting x value 2.62 minus 4 into 2.62 minus 9. This value gives 0.0144, where it is a positive value. Now again, the b value will be changed to the 2.62. So for third iteration, a value will be same, but b value will be 2.62, and then f of a will be same, f of b will be 0.0144. And now again, finding out the c value by using this formula, you will get 2.62 and the root value is 0.0144. See, since I taken only up to 2 decimals, the number of iterations become only 3. But if you move on to 3 decimals or 4 decimals, this might not be the end point. It might be, it can take 4, 5, 6 iterations, and then we will get the root value or the approximate value. So now as I took 2 decimals only, value is repeated. So here again what? A value will be same, B value will be same, and here f of a is same, f of b is same, and c is same. Again the value will be same, since it is only up to 2 decimals. So here the root value of the function is 2.62 and the function value is approximately equal to, the function value is approximately equal to, function f of x is approximately equal to 0.014. So in this way, we will find out the root of the given polynomial by using Regula Falsi method. And the content is taken from SS Sastry, and the problem is taken and the theory is taken from the given online resources. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.